Hi guys, this is Professor H2o with Nutty Scientists, and welcome to our at-home lab. So today, we're going to be doing the magic of science. These experiments truly are magical, and they use items that you may have around the house, like water bottles and things like that maybe you can try them at home once you see the science behind them. So, first off, every scientist gets a little thirsty, especially when their name is Professor H2o, which is a fancy word for water. So before I was starting my show, I was really thinking, what kind of things that I would like to drink. I could make some lemonade. I could make some soda. That'd be really good. That's not a good start. Luckily, I have lots of these cups, but this can't be good. How am I supposed to get all my drinks? Maybe the store sold me some cups that weren't very good, huh? I think I'm just going to overload it. Then one of these cups will really start floating, and they'll be nice and cold with this nice cold liquid. What is going on? Good thing I didn't put my fabulous drinks in here. Otherwise, that liquid would have gotten all over me. Anybody know what's happening? I'll let you see the inside of this. All of my cups are turning to goo. That can't be good. What do you think? How many cups do you think that it'll disintegrate? It's just turning it into a paste. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 cups. There's no way that this mystery liquid can dissolve 13 cups, right? Because now I just have to know. I'm a scientist. I gotta ask questions. So even though all my cups are disappearing, I have to know how many of cups this stuff can eat. Let's see. This was 13. I don't think there's any way. I think it's going to run out of liquid or something. This is just so interesting now. It's like you're making cups too. Wow. Let me move this closer so you guys can see. As soon as I press it under the water, it turns into a paste. Almost like magic. Huh, what a coincidence. So do you think this stuff is water? Have your cups ever done this in water? Mine sure haven't. It also is making a strange bubbling sound. You're right, it's not water. What this actually is a chemical. I did get some on my hands earlier, but you see that it's a chemical that I'm pretty familiar with, that it doesn't really bother my skin too much. And you probably have some in your house too. It's called acetone. And you use this, or your mom might use this, or your sister, to get the nail polish off of their nails. But this is really interesting. I wonder, as we do more of our magic tricks, if this stuff will eventually disappear. Kind of looks like slime, but this is not a slime you really would want to play with. It's pretty awesome. So, I probably should be wearing gloves, shouldn't I? I was not a very smart scientist. But, if you end up doing this at home, make sure you wear gloves, okay? Alright, we're just going to let this sit here. And maybe by the end of the show, we can look at it again, and you can see what it turns out to be. Awesome. Unfortunately, I'm still thirsty, but after seeing what was in this bin, I'm definitely not drinking anything else on this table. Alright. So, now for another cool trick. I have here a lot of liquids. Let me move our acetone out of the way a little bit. And bring in the graduated cylinder. And these are really awesome. We do all kinds of fun stuff with these. It actually goes to 1,000 milligrams. So, we're going to play with some more liquids today. And we're going to separate our liquids. Some of the liquids that we have our lamp oil, rubbing alcohol, vegetable oil. What else do we have here? Some plain old water, some good old H2o, some dish soap, milk, syrup, like a waffle seed, corn syrup, and honey. Now what happens if you pour two liquids in the same cup? So if one of my cups had survived, and I poured some soda, like some Coca-Cola, and some Sprite, and mixed it together, what would it be? It would be a really nasty soda. But I want to keep my liquids separate. I want to keep them and try to stack them on top of each other without mixing. Do you think that's possible? That we can stack all of these liquids on top of each other in this graduated cylinder? We should try it. But to show you how cool this experiment really is and how magical it is, I'm actually going to add the liquid here, lamp oil, first. See, if I just pour all these different liquids in, it might mix up and it would probably turn into a nutty mess. But what I have here are liquids that are different densities. That means their weight is different. Lamp oil here is one of the lightest materials that I have. If you look at how it moves, you see how it's splashing around. Do you think that would happen if I did that to my honey? Do you think that it would splash like this if I went like this and it would just splash all over the place and move really quickly? That's what I say with density. This is one of the lightest ones I have. So if I pour this in first, let me show you. Why talk about it when I can show you it? That's right. Alright, I'm going to be very careful. This is stuff you put in tiki torches. That should be fine. Alright, so here I have my lamp oil. The first thing that I'm going to add to my graduated cylinder after that is some honey. Now notice the difference in how this honey moves versus my lamp oil. And see if they mix together. Wow, look at it move real quick through that lamp oil, huh? Okay. Well, this is going to be messy. I hate messy stuff. But you guys, I'll do it. So, there we have it. You see how my lamp oil stayed right on top, and all of my honey sunk to the bottom. How cool is that? Alright, so the next liquid that I'm going to add is my corn syrup. Let's have this guy, another slow mover. Look at this. So what we want to happen is that the corn syrup will sit right on top of that honey. Or it'll make sense. What do you think? Yeah. Alright, so it's going to settle, and you'll see a nice line in between my honey and my corn syrup. Check that out. And as we go, and it sits a little while, it'll separate even more where the corn syrup will rise to the top of the honey. Alright, this one might be easier to see because it's got this good brown color. Does anybody remember what this one was? Maple syrup. Alright, there it goes. I wish I had a big stack of waffles for it. If you look, it pours a little bit faster than my corn syrup and my honey did. Well, let's see if it sits on top of that corn syrup. There we go. Look at those layers. I've got my honey on the bottom, my corn syrup, and then my maple syrup. Awesome. See, we're making a liquid rainbow. And if you notice, all my lamp oil still looks real clean, doesn't it? Alright. Next we have this, a very recognizable liquid. So this is going to pour a lot faster than even the last thing, the maple syrup. Through the lamp oil, wow, look at those bubbles. Through that lamp oil all the way to sit on top of my syrup. And I like those little specks of the milk that it's got going on. What also could be happening that I didn't even think about is that the lamp oil could potentially decompose some of my milk. So maybe some of those particles are rising to the top because of that. Alright, next up, dish soap. Nice and green so we'll be able to see it. Alright, let's see. It looks kind of cloudy right now. Let's see if it'll settle. Ooh, look at that neon green. Alright, let's watch for a second. If you see down here, it's nice and dark green. But here, it really did cloud up my lamp oil. Let's see if it'll settle, and it'll sink back down to the bottom. It may take a couple minutes, so we may move on. But if you look at my bottom layers, you can really see all of these things stacked on top of each other. We've got 1, 2, 3, 4, 5, and then my lamp oil. So 6 layers so far. Alright. Here's the hardest one. Water. You might say, why is water the hardest? Water should be the easiest. I should be the expert at water. But unfortunately, because it's right on top of that dish soap, sometimes we just end up with soapy water. What I'm actually going to do too, to make sure that we can see it, is add food color. Just a little bit. We'll make it blue. So, you might be wondering, won't that turn my lamp oil blue? The answer is it shouldn't. They actually, right here, I have a special oil dye that should dye my oil. But this stuff is so thin that hopefully the food dye won't stick to it. Alright, are we ready? Let's see how this goes. I'm going to do it really slowly. That's actually why I brought my little face thing. Oh, that should be pointing. I want to do this as gently as possible. Let's see, we're hoping to see that blue line right on top of the green. Looks like it's doing a pretty good job sitting on top of the dish soap. Awesome. Really cool. I am pretty impressed that actually there's parts of the milk stuck in the lamp oil and really made it a little murky. Alright, next we have our vegetable oil. And a lot of the times you may cook with this stuff at your house. Again, we're just getting thinner liquids. So this should be lighter than water. It's still heavier than our lamp oil. So it looks like it's just sitting right there. We'll give it a second to settle. This one's kind of hard to see, huh? Probably because the color of the lamp oil. You can see it a little bit. Alright, so I only have 2 liquids left. I have my rubbing alcohol and my lamp oil, which is supposed to sit on top. So this rubbing alcohol, it should just be a little bit lighter than my lamp oil. Let's see how it does. See it sinking to the bottom, or not the bottom, but the bottom of the lamp oil. Check that out. Can you see it falling? That is really cool. Nice. Alright, so we've got some really nice layers. I'm going to add my last bit of lamp oil. It shouldn't really do anything. It makes it on top of the older lamp oil because it's got particles of the other liquid in it, but it looks pretty good. Alright, now, just to show you what I mean, you see how this did not dye. I poured this food coloring in there, in the water. My lamp oil didn't turn it blue at all. So, let's see if I can turn it red so that I can show you. I don't even need that much. That's a lot. There we go. So that is oil especially made for the lamp oil. Give it a swirl. You see how my different layers move? Well, let's see if this, oh, that's probably the dish soap and the water mixing a little bit. My milk does not look like something I ever want to drink again. Alright, so we'll let that be. It still looks really cool. Alright, so now before we move on to our next magic experiment, I'm going to show you. You've ever played sink or float, where you put an object in water and then you see if it'll sink to the top or sink to the bottom or rise to the top and float. So we will play sink or float with my density tower. And we will try to make things magically stay right in the middle. What do we think? So if you were to drop a ping pong ball in a thing of water, would it sink or float? It would probably float. Let's see where this ends up. It is even lighter than my lamp oil. Pretty cool. What about a dice? Like in a board game? Where did he end up? I think he's sitting on top. Oh, you know where he is? He got stuck right here. He is in the middle of my maple syrup. You see him? No, he is right there under that 100 milliliter. There he is. So he was lighter than my bottom layers, but it was a little bit right there, heavier than the milk. Okay. Let's see. That'll probably be the heaviest thing I have. I don't know. Maybe this guy. This is one of those rags that maybe you make a clock out of at school. I'll drop a couple this time so you can see where he lands. They're getting lost in my tower. Ooh, see, they were even heavier than the dice were. They sunk all the way down there. Even past my corn syrup. Alright, I've got a bead. Where'd you go? I should use lighter liquids next time, huh? I think he's in my maple syrup too. We will do a couple more beads just to see. Put them in different spots. Hopefully you can get them on the edge. He's floating around right above my dish soap. You're not going to be able to see him, but I saw a glimpse. And then I have a popcorn kernel. Do you think it'll float? It's nice and light. Again, he's stopping right here, just where everybody else is. And last one, bottle cap. Now, if you put this on a thing of water, it probably would float right at the top, right? Let's see where he ends up. Well, they really like, I think there's quite a few things right about here. I'm going to make sure I can't see anything else to show you. Oh, yep, there he is. So my bottle cap sunk right there, right above that, at the bottom of my lamp oil. Pretty cool. I hope you guys can see that. I know it's a little murky. Alright, and I think I added all of my items. Might as well just throw them in there, right? And there we have it. The density tower. Ooh, look at all these stuff right there. Look at that bottom maple syrup layer. All kinds of stuff stuck in there. But that's a density tower, so I have magically stacked all of my liquid and all of my atoms. Pretty cool, right? I really love how it moves. These thick layers are moving nice and slow, whereas the higher you go, the faster it moves. Pretty cool, right? All right. Awesome. That was really cool. It makes me really feel like I'm honing my magician skills. All right. So the next thing we have is this experiment. A couple bottles, a straw, may not look like much, right? Very expensive, very high tech. And we definitely will need this because I have a feeling we're going to make a very large mess with some H2O. All right, let me move this out of the way. Let me show you first, though. It is really getting pretty stringy. Whew, and smelly. My goodness. Okay, so next experiment, magic. Are we ready? All right. So the first thing I need to do is pour water. Now, how would I be able to get water out of my container and into the bucket? Or the bowl, I guess we should say. Any ideas how I would be able to do it? The easy way to do it, a couple easy ways. One, you could just tip the bottle over. Or two, I could fill it up past the straw, and it may be dripping a little bit, but it's okay. We'll figure it out. So, I could just fill my water level over my straw, and then, I'll show you, it'll just drip down, right? A little bit higher. See? But the problem is that once it gets past the top of my straw, water's not going in there anymore. So that's why we're going to use the second bottle. What we're going to do is try to make a siphon. So right now my bottle has lots of air in it, right? Air. And I'm going to put this over my straw. Still nothing coming out of the bottom. And check it out. How am I performing this spectacular magic? The answer is that right now, the water is coming out of the bottle, right? The water bottle. And to replace it, it wants to pull in air, but it can't. So it has to pull in water. So that's how I drained all of that water into the bucket, even though the straw wasn't underwater. Pretty cool, right? Pretty cool. And I've got all this water to use for other experiments. Speaking of other experiments, why don't we do another H2O experiment? Because I love my H2O. Okay. Let's see if I can do this without making a mess. Who thinks I can do that? If you know me, you know I love to spill water. Not on purpose, though. That's why I'm using a funnel. Just so we don't have to get new water, we can reuse this for our other experiments. Alright, so this next one's really tricky. So we're going to see what we can do. Alright, why don't I show you first? This actually has two parts. I will show the magic trick to you first, and then I will explain the science behind it. Sound good? Alright, so the first thing I want to do is pour water into my jar. What did I say? Always a mess. Where's my bowl? Not even a funnel could help me that time. That's okay. Science is messy, isn't it? I hope that you guys aren't being too messy with your parents learning all this science at home, huh? Alright. So, there we have it. So, there's water in my jar. No tricks, it's not magic. I'm a scientific magician. I'm not a real magician. Alright, so I said that this trick has two parts. The first part is, I want to flip this upside down, and I want very, very little water to come out of it. You think I can do it? If I just go like this, all the water is going to come out. You saw me pour it out right there. So I'm going to try and use this card to flip it. Make sure it's nice and even. Well, there we have it. How? How do you say? Right. See if I can put it in here without dripping it everywhere. Pretty cool. No magic. I told you, I'm a scientist. Next thing I want to do is I want to put these toothpicks, I forgot earlier, I was just going to put these toothpicks in the water before I filled it up. Now I have to do it after while it's hanging upside down. This is going to surely be a mess. Alright, let's see if I can do it. Check it out. Did you see it? Let me do it again. I'm going to find... Oh, that's not a good spot. I don't want to tip it over. There should be 2 in there. Uh-oh. It's kind of good that water's dripping down a little bit. That way you know it's stuck. There we go. How cool is this magic trick, huh? But I told you it's not magic, it's what? It's science. Awesome. You want to see how I did it? First off, I don't trust this. You ready to see the water come out? Ta-da! And there's my toothpicks. So, if you look at the top of my jar, it's got all this medical mesh on it. It's got little tiny holes. And if you see, some of the holes are bigger than other ones. That's why I had to look underneath when I was putting my toothpicks in, because I had to make sure it was one of the bigger holes that it would just slide on in. But what happened is the water molecules, the H2o, stuck to my mesh and formed a barrier that didn't let this water come out. So they basically made a giant net that kept all that water in there. Pretty cool, right? And as long as it's nice and steady, I didn't break the surface tension when I pushed those toothpicks in. That's a really cool magic trick, isn't it? If we had all day, I could try and get all of these toothpicks in. That'd be pretty cool. Alright, you guys want to see something else? Perfect. Let me move this out of our way. We could do our next water experiment, or I could save that, because I do love water. Yeah, let's save that one for later. Alright. How about this guy? Alright, so these are called Newton's beads. And we're going to try and do something really cool with them. So again, I ask you the same question. What's the fastest way to get these beads out of the cup? You might say just tip it over, but that's no fun. So right now, you see, it's just hanging over just a little bit. What I want to try to do is make these beads lead the way so that all of these other beads will follow them. You want to try it out? I'll show you what I mean. I'm going to do this a couple times, so hopefully we get a good one out of it. Ready? Did you see it? That was pretty cool, huh? So, these beads, I have to organize inside. I can't just throw them in here. I laid them gently. Well, actually, we can try it. We can try the difference. I'm just going to really just throw it in there. Maybe put some knots in it. Let's see if it still works. That would save me in the lab a lot of time. Ready? Nope. So science requires a little bit of preparation, huh? But luckily I've got these two prepared. Then maybe we can try the experiment again. Well, I did have an edge. There it is. So the higher I hold it, hopefully the bigger loop that we're able to get. See, it's already trying to go without me. Ready? How awesome. So what happens is that one of Newton's laws says that an object in motion stays in motion until another force acts upon it. So in this case, the other force, the beads were holding it back. They had to untangle themselves. But if I had all these separated and ready to go, there's really not a lot of force that's trying to hold it back. Alright, so this one's a little bit longer, so hopefully we'll be able to see a really good reaction. Ready? There we go. How cool. So that is probably not as fast as just tipping it over, but it's a way cooler way to get all of my beads onto the floor in a giant mess. And it does look like magic. It looks like I tied these, and if anybody's seen my videos, you know about Professor Molecule. It looks like I tied an end of these to Professor Molecule, and she ran away and pulled all the beads behind her. But no, it was just science and all of Newton's laws. Pretty cool, right? Again, you want to detangle us? We'll save this for Professor Molecule. Maybe he'll help me. All right. Pretty cool. See, we've got all these awesome magic experiments that there's a science to it, which makes science even more awesome, if I do say so myself. All right. So why don't we've done water, we've done liquids. Let's do some air. Good. I needed a good hairdryer in my life. See? Can you recognize these? Alright, so we're going to do some science with a hairdryer. We could test the temperature. That'd be fun, but not as fun as this. Alright? So, I have a balloon. I got some ping pong balls. And a craft tube. So again, some of the stuff you may have at your house, but you can try it. Maybe your mom has a hairdryer. Just don't do it near any H2o because that's not good. Alright, so we're going to use something called Bernoulli's principle to perform magic. Are you ready? Ta-da! Just kidding. There's just a ledge on it. Alright, you ready to see it for real? I'll start low. There we have it. You see it's hovering like a hovercraft. All right, let's move it to high. So cool. You ready to see something else? Did you see I was tilting it? It's pretty awesome, right? All right, let's try and get... This may pop my balloon, but we'll find out. Science is all about experimenting, right? I say that because of the heat. So these are really special balloons. So you see that it says pull, because they light up. They're my favorite balloons of all time. See it? We'll make it nice and small. That way, hopefully the rubber can withstand a little bit more heat. Alright, so let's try a balloon and a ping pong ball. Ready? I don't know. Look at that! How cool is that? You think we can go sideways? Which one's gonna drop first? The ping pong ball! I did not, that balloon was so far. Let me show you with just the balloon. That was really cool. Wow. I wanted to be part of my density tower. Alright, wasn't that so cool? I wish I could set this one free, but it's already tied. Love these balloons. Alright. He has no home though. We're just gonna... Okay. So, let's try something else with the ping pong ball. We're going to speed up our ping pong ball. Are you ready? Did you see it? That was a cool one, huh? So, let's see. Let's try it again. I should probably put the ping pong ball first, because I think this isn't going to work so well. Let's try. Oh my goodness, I am really having a hard time. That was a high one. I don't know if you got to see all that. That was really cool. So that actually looked like, the closer I hold the craft tube to the heat or the source, it looks like that's the farthest it'll shoot up. Ready? I didn't do it right that time. We'll try one more time and then we're done. Oh my goodness. I lied. I have to try once. There we go. Did you see that one? That one was really good. I hope you guys got to see how far that one went. Alright. Should probably clean up these ping pong balls. Give me a sec. That one was really fun. I hope that you guys can try that one at home, because that one's really great. But I did forget to tell you about the science behind it. I completely forgot. So, Bernoulli's principle, the air is coming around my ping pong ball, and it's doing it in a way that's just it's just surrounding my ping pong ball and just keeping it in place. And that's why it's not really floating and shooting off into outer space or to the left, to the right. It's just kind of holding it there because the air around it is just circling it. Pretty cool, right? So, we have 2 more experiments, both with water. So they're both awesome, of course. Let's do this one. I've been thirsty all day, see? Now, I wish that I could drink this soda, but really it's just for science. I wonder who's seen this one. But if there's any that you can do at home, this is definitely one, because all I have is a soda can. It's empty. I've got a couple drops of H2o in it. I've got some water. And I have a funnel, just because I know myself. So what I'm going to do is, I emptied all the root beer out of this, is I'm going to pour this water in. This is not just a random amount of water. I had to play around with it a little bit to figure out which one is going to make this magic trick work. Okay, you also notice I have a tray, because the many times that I've practiced this experiment, sometimes it works, sometimes I make a mess before I get it to work. So, let's hope that it works first time. What I want to do is there's water in here now. I want the water to move the center of gravity of my can to perform magic. Right now my can is happy. It's nice and level. But I want that water to hold my can in place. Like this. You think it's ready? 1, 2. Check it out. Pretty cool, right? So that water is just sitting there, and it's holding the can down so you can spin it. Now I look like a true magician, don't I? See? That's why I have to have the tray. But sometimes when there's less water, I get an even more perfect amount and weight distribution so that I can go all the way around. Let me move it closer. So you can see it. But that's really cool, right? It's called the spinning pan. The weight of the water is really holding it in place in a very odd position that doesn't look possible. Pretty cool, right? And I didn't spill that much water, just a little bit. Alright, one last magical experiment. My favorite. H2o. So this is called Phenol Blue. I'm sorry, there's no bromophenol. I can't even say it. See, you don't have to be a perfect scientist, right? Science is all about making mistakes. Here, you can eat it. Alright. So what it does is it tells you if something is an acid or base or neutral. And it's talking about pH levels. So that what makes the liquid up what really is the pH level of the liquid. So water is in neutral. So that means that when I put this magical liquid in, it should turn it purple. Or maybe even blue. So that's showing me a little bit more that this is not acidic and it's not a base. It's pretty neutral. But say, for instance, I don't like the color purple. I do. I love the color purple. I love all colors. But maybe I don't today. Maybe I'm not in a purple mood. We're going to see if we can change the color from purple to something else by adding vinegar. Check that out. So now, since I added vinegar, it has a different pH level. It's showing me that my water is now acidic. And it turned it yellow. Really nice shady yellow too, huh? That's just so beautiful. Alright, I'm done with the yellow. I want it purple again. Think we can do it? So we will add these alpha salsa tablets, which is what you take if your stomach feels super rumbly or maybe super acidic. Let's see if we can change it back. Look at that. It's turning back to purple. It's breaking down all that acid from my vinegar. And it looks like magic. Pretty cool, right? I wonder if it would change the color of my density tower. What do you think? You think it would? I said that was the last experiment, so now I have to know. I've got this stuff. I've got my density tower. How could I not? Let's see. Let's see if it changes the color of any of my liquids. Well, it'll change the color of the water. I don't even know if it'll sink deeper or not. Interesting. So I think it only changed the color of my water, nothing else. It should change the color of the milk if I can get there. Maybe it's turning it a little yellow. Well, it shouldn't. It shouldn't turn it yellow. Because that's for an acid. We can also add a little bit to my acetone. Oh, you want to see my acetone cup mixture? There we have it. Those cups that I was drinking from earlier. Final product. Goopy mess. Wow, this color of purple is really great. I'm loving this. Do you think my acetone will change color? There we have it. Pretty cool, right? It didn't change yellow like the vinegar did. It changed the other way. So that means that it's more of a base. I'll add a little bit more because it's a lot of acetone. Pretty cool, right? Again, magic of science. I hope that you guys learned something. I hope you had fun. We did all kinds of water experiments. We had our Newton speeds. We had our can dance. We had our air experiments. We had our density tower. We've done a lot, haven't we? We've done a bottle experiment. Pretty cool. And I'll see you next time, guys. Have a good day. Bye.